Hey guys, welcome to the end semester project presentation on the topic credit card fraud detection using machine learning. As a part of this project, we utilize various machine learning algorithms available on a publicly available data set for credit card fraud detection and analyze the results. The video will give a brief idea on the selected data set, the environment to execute the code, the actual source code, and the scripts used to train and test the data, and finally, a deep analysis of the entire evaluation metrics. Without further ado, we'll hop on to the actual source code and the data set. So as you can see on the screen, this is the data set that we have chosen. This is available publicly on Kaggle, and it contains fraudulent transactions and normal transactions. Uh, this is Google Colab, which is a environment which we have chosen for computing the code and testing and training the machine learning models. So uh, we first imported the Python tools and libraries, which will be used as a part of the code. Then we imported the dataset file in the code using the Panda commands. Then we performed the analysis on the data, imported data. That is, we saw the first few rows, the last few rows using the head and the tail commands, the shape, the information, data types of different data columns or data values in the dataset. We also plotted a bar graph for better visual presentation. We found out the count, mean, standard deviation values, the fraud counts, etc. This was the first step, that is the data analysis. We then moved on to the data pre-processing, which involves the data cleaning and data reduction to remove duplicate or missing values and to reduce the noisy data and make a clean data, which can be then fed to the machine learning algorithm. For this, we first remove the duplicates by using this command, and we check that the duplicates uh, left in the dataset are zero. Then we remove the null or missing values. And finally, we perform data reduction. For that, we analyze the unique count, the unique values in each columns. And we realize that there are certain columns or data sets, datas that are not required for training the machine learning. So we remove data such as first name, last name, state, city, population, etc. And we got a final filtered data. Then we perform feature extraction and data transformation. In this, basically, there are multiple formats of data in the available data set. So we converted the data into one single format, that is the numeric format, which helps the machine learning to analyze the code quickly. Uh, Now, the next process is the data training and processing. Here we have two approaches. One is without sampling, and the second one is with sampling. First, without sampling, we split the data into two parts. That is a train and test data. Train data is used to train the machine learning model, and test data is used to predict the values. Uh, so we divided the train and test data into 70 is to 30 ratio. The train data consisted of all the columns other than the target label, that is this fraud, whereas the Y train consisted of only the is fraud column values. Similar is the approach for test data. Now we perform data modeling. In this, we have selected random forest classifier as our machine learning algorithm. So we imported the method, and we trained the data, trained the machine learning model using the X train and Y train values, and we predicted the values using the X test. Now we go on to the evaluation matrix. In evaluation matrix, we basically predicted the accuracy, precision, recall, F1 measure, AUC, ROC curve, confusion matrix values. These values are as shown on the screen. Here we can see that it has a good accuracy and precision value. However, the recall value is very low, is significantly low, and the number of false negatives, that is, the transactions which are actually fraud but are not detected by the model, are quite high. So what we do is we now sample the data using smart sampling method, which is an oversampling method. This makes the data even. After sampling the data, we again perform data modeling. Here we again use a random forest classifier, and we feed the sampled data to the machine. So it analyzes the machine trains itself on the basis of this code and then predicts a value basis on the X test value. The evaluation metrics for this is again we find the accuracy, precision, recall value F1 measure, AUC, ROC curve confusion matrix for the same. Here we find that the number of false negatives have significantly dropped, that is 534, indicating that a good detection and prediction capability of the machine learning model regarding the fraudulent values. Also, the number of fraudulent values have detection of fraudulent values have increased. That is a true negative. Also, as we can see, the recall value and the F score value have significantly increased. So, after performing analysis on both the approaches, we can say that the random forest classification is one of the best methods available for detecting credit card fraud, for detecting the fraudulent transactions in credit card and ensuring that we use sample data using smart sampling technique. We can get better results. So, in the end, I would like to conclude by saying that for this research problem of detecting credit card frauds, we have used random forest classification method, which is a supervised learning method, and we have used a publicly available data set which we have sampled uh, to generate better results. Thank you.